Hi class, this is going to be the sequence and series lesson. I am not going to be in class today. I am going to send you this video as to help you how to do these problems from the homework that's due tomorrow. We're moving on to new topics. As of now, we have finished all of Unit 2. We're starting a new lesson from Unit 3, and they start with sequences and series. So first, if we go over the sequences, um, let's see. A sequence here is a set of numbers in a particular order or pattern. Each number in a sequence is called a term. So what does that mean? It's basically a list of numbers. So 1, 2, 3, 4, 5, 6. We have all been encountered our first sequence and series at a very young age. This is a sequence of terms, basically. So each of these are called terms, and the list of terms that has a pattern, because every single time you're adding up by ones, that's called a sequence. Now, there are going to be two different types of sequence. There's going to be first arithmetic sequence, and we're going to talk about geometric sequence a little later. But arithmetic sequence basically has what we call a common difference. In a sequence, like as you see down here, we have 3, we have 6, we have 9, 12, and 15. Now, these are called terms as again, and now we have a list of terms that consists, which makes a sequence. Now, in this sequence, you see the pattern is that you add up by threes every time. So, when you have a sequence that has a pattern in which it adds or subtracts, it's going to be arithmetic sequence. As you see up here, each term is determined by adding a constant value to the previous term. Now by adding, you can probably add -2 to it or something, so you can still think of it as subtracting as well. So as long as it's being subtracted or being added among the terms, then you know you have an arithmetic sequence. Okay, pretty simple enough. Now let's do some practice with this. All of these questions are straight from the textbook that are uploaded for you. It's a chapter 11 arithmetic, or actually it's sequence and series. Um, this is going to be just 11.1, talking about the defining the terms for arithmetic and geometric sequence. Now the very first question you will encounter is determine whether each sequence is arithmetic. So what you're going to do is you're going to take the second term, for example, and then you're going to take the first term, and then you will basically see the difference. Oh, from 5 to -6 to go there, I would have to subtract by 11. Make sense? Now you're going to check the second to the third one, and then you will see the pattern in which, in order for you to get from -6 to -17, you would have to subtract by 11. And again, from -17 to -28, you will subtract by 11, and all the math checks out in which the pattern is consistent. You know you have an arithmetic sequence. Now for the second one, you have from -4 to +12, which means you added 16. Now the easy way to think of how to get these numbers is take the second term, basically the one that's next to, and the -4, that's the previous term. So it's like next term minus the previous term. So 12 minus -4 gives you the 16. So that gives me like the difference between the two terms. So from here, on my first question, I took the next term, which was -6, and I subtracted the previous term, which was 5, and got -11. And either way, you want more format, you can use these formulas, or if you can just take a look at these two numbers and just tell me the difference right away, you may do so. So you have +16 here, and then you're going to check the third one and the second one. Again, this will be your next, the third one, and the previous term will now be your second. And so 28 minus 6, I'm sorry, minus, I don't think that's a dollar. Wait, I'm going to just change this. 12 is equal to 16, and that's 16 here. And now you're going to take 42 minus 28, And then now notice what happens is that 42 minus 28 gives you only 14. So this is going to be a no. The pattern, the first two stays consistent, but the last one doesn't. So it's very important for you to check all the difference to make sure that it's going to be an arithmetic sequence that is among every single term. So you have to find the pattern, you have to find the difference. You have to look for the common difference for every single terms between the first two, between the second two, and between the last two. Okay? So I'm going to leave the guided practice for you to do as of now, but I believe for this one, it's going to be a no. And now for this one, I think it's going to be a yes. Okay? Make sure you find the difference among 7, 12, 12, 16, 16, 20, and you will see that the difference doesn't match. 6, negative 6, 3, 3, 12, 12, 21, and you will see the difference matches up, so that will be an arithmetic sequence. Okay, moving on. Now, another question that they might throw at you is something like this, where they're going to say, I'm going to give you the arithmetic sequence, so we know that there's going to be a pattern of adding or subtracting by a consistent number. Now find the next 4 terms of the sequence. Okay, no problem. 18, 14, 10. What's the common difference? Obviously, it's going to be plus 4. You're going to be adding 4 every time. So if I want to find out the next 4, oh, I'm sorry, I'm not adding 4, I'm subtracting 4. Subtracting 4 every time. So find the next 4 terms of the sequence. I'm going to subtract 4 again and get a 6. Subtract 4 again, I'm going to get a 2. Subtract 4, I get negative 2. Subtract 4, I get negative 6. So these 4 terms will be my answer. Now find the next 4 terms of the arithmetic sequence, 18, 11, and a 4. I will leave that for you guys to do. Now, another type of sequence, as we discussed before, it's called geometric sequence. Now, geometric sequence has something called a common ratio. Now, if arithmetic was plus and a minus, geometric is multiplied or dividing. So this is arithmetic. Multiplying or dividing is geometric. Okay, so each term is determined by multiplying a non-zero constant. It's a fancy word of saying multiply anything but 0 by the previous term. So here, if you take a look at the sequence, these are the terms: 1 over 16 to 1 over 4 to 1 to 4 to 16. Now, when they throw fractions at you, it might not be as obvious, but if you take a look to 1, 4, and 16, you can tell that it's being multiplied by 4, and also the fractions, if you keep on multiplying by 4, you will get those guys. 1 over 16 times 4 over 1 is the same thing as saying 4 over 16. Reduce it to 1 over 4, which is your second term. So everything checks out. So that's going to be classified as a different sequence called geometric sequence, not going to be arithmetic. Now, determine whether each sequence is geometric. So here, if from the previous part, we learn that we subtract the next minus previous to find what we call the common difference, in the geometric sequence in series, we're going to be doing what we call next divided by previous to find out what we call the common ratio, right? So the next here will be 6, the second term. The previous will be the first term, will be negative 2. And if you divide those two, you get a negative 3. So to go from negative 2 to positive 6, you have to multiply by negative 3. And it makes sense. So the whole purpose of me doing next divided by previous is just so that I can know my common ratio. Then, from second to the third, 6 to negative 18. 6 times negative 3 does indeed give me negative 18. And negative 18 times negative 3 gives you positive 54. So yes, that is definitely going to be the geometric sequence. And if you want to determine it, you can just show that the common ratio is consistently multiplied among the terms. Next, 8, 16, 24, 32. Now, next divided by previous would be 16 divided by 8, which is 2. So that's being multiplied by 2. And that is also has to be multiplied by 2. But what do you notice? 16 times 2 gives you 32. That's the fourth term. But the 24 is in there, which means it's not consistent. 24 times 2 certainly doesn't give you 32 either. So this is going to be no. It's not going to be a geometric sequence whatsoever. All right, moving on. Now, guided practice, determine whether each sequence is geometric. Now here, I'm going to leave these two for you to do, but I believe this one is going to be a no, and this one is going to be a yes. And the common ratio here, I'm going to just call it CR, should be 1 over 4, or actually negative 1 over 4. Same thing as saying divided by negative 4. Okay, so try this. You remember the next divided by previous to find out the common ratio, and if it's consistent, you know you have a geometric sequence. Determine whether each sequence is arithmetic, geometric, or neither. So this is going to be the last part for today. So in order for you to determine whether it's geometric sequence or arithmetic sequence or neither, you first really have to look for either the common difference or common ratio. So which one is going to be consistent here? So now, here you have 16, 24, 36, 54, and so forth. Now, automatically, you can kind of take a look at the sequence, like kind of scan it through, and determine which one is really not the obvious choice. In this case, there is no way this is going to be geometric. It's not going to be geometric at all because you know from 16 to 24 or 36, 54, and so forth, if you wanted to multiply, 24 divided by 16 does give you 1.5. Oh, actually, right, so this was my fault, making a lot of mistakes today. So actually, scratch what I just said there. Let's go back. You're looking for common difference or common ratio. Next divided by previous gives me 1.5. Now, if I do 24 times 1.5, does it give me a 36? Yes, it does. And if you do 36 times 1.5, it does give you 54. So this is going to be a geometric sequence because you found the common ratio and you applied it to every single terms, and then it does give you this correct sequence that you see at before you. So here now we have 1, 4, 9, 16. Now, if you were to find the difference to check to see if it was a arithmetic, you will see that this is a plus 3, plus 5, and plus 6. Oh, I'm sorry, plus 7. It's inconsistent, which means it's not going to be an arithmetic sequence at all. And so then, does that mean that it's going to be geometric? Well, to go from 1 to 4, you need to multiply that by 4. But if you multiply 4 by 4, you get 16, not a 9. So that means it's going to be neither, because you're not going to add by the common difference. You don't add by the common difference. You don't multiply or divide by a common ratio. So therefore, it's going to be neither. All right, next. Scratch this. This part is just unnecessary. So determine whether each sequence is arithmetic, geometric, or neither. Explain your reasoning. So this was the same question as we did before. So guided practice, these 3 questions I'm going to leave for you to do, but I'm going to just go over this with you one last time just so that you have an understanding of what's going on here. So here we have 5 over 3, 2, 7 over 3, and 8 over 3. Now, I know we don't really like to do work with fractions, but what we're going to do is we're going to take this one at a time and then see if there's any patterns to it whatsoever. Now, it might not look as obvious, but if you change this changes 2 into a fraction, you have 5 over 3, and 2 into a fraction that has a common denominator of a 3, your numerator should be a 6, right? So 6 over 3, 7 over 3, and 8 over 3. Hey, what do we know? What do I know? It's definitely going to be an arithmetic because you add by 1/3 every time. You see that? So if you add by 1 over 3 every time, you will get those sequence. So this is going to be arithmetic. Next, you have 2, negative 3 over 2, 9 over 8, and negative 27 over 32. Okay, so the biggest thing is you really don't know, okay, this is going to be arithmetic. Do I need to look for common ratio or do I need to look for common difference? Either way, it's best if you just can check for both real quick. So first here, what we're going to do is we're going to take a look at the next minus the previous or anything that can help you with just determining what these numbers is going to be. Now, in here, you can try various different methods, but what I notice is that, I see fraction here and I see a fraction here, and then I see another fraction here. Um, to go from 3 over 2 to 9 over 8, you have to multiply this by 3 over 4. Now, of course, you can do your next divided by previous from the second and the first term, and then get your common ratio. Or you can try first doing, your next minus previous to find out the common difference and try to check to see if it was arithmetic. But you will find out that this is going to be it's going to be the geometric sequence with a common ratio of negative 3 over 4. So it's going to be geometric. You know how to determine arithmetic and geometric at this point. It's just that it's tedious to try both ways. But in a sense, as of today, if you can determine what that means, and if I give you a series relatively easy enough for you to do to determine whether it's geometric or arithmetic, I think that's the main goal for today. Now the last one, negative 4 to 4 to 5 to negative 5. Now this is a little weird because here, it seems like you're multiplying by negative 1 or adding by 8, but you're adding by 1, or you're adding by 1, that's the only way, and then you're multiplying by negative 1. So you have a mixture of these multiplications and plus 1, so it's going to be neither. Okay? All right, so moving on. This is going to be your independent practice for the day. Make sure you take a look at all these questions, okay? Try to see if they give you arithmetic sequence, you know that you're looking for a common difference. So don't even bother looking for common ratio. When the question is geometric, then you know that you're looking for a common ratio. So find next terms of geometric sequence, so still geometric. Only when you have this question where it asks to determine whether it's arithmetic, geometric, or neither, then you have to look for all these different possibilities. That's when it gets a little tricky. So there's question 1 through 20. Question 1 through 20. You may work in groups, you may work in pairs. I would like you to finish this and take that as a classwork and submit it to your substitute today. Your homework will be on the slides. It's just going to be odd problems. So from 21 through 50, I would like you to just take a look at the questions that you have on these two slides and then just work on the odd problems for me and turn it in by Thursday. Okay, and I'll see you guys Thursday. I hope my leg gets healed by that time, but I'll see you guys on Thursday. Okay, have a good day.